Hi friends, welcome back. After introduction about the topic data structures, let's begin our real journey into the data structures. There are many types of data structures classified as linear, non-linear. Under non-linear, it can be a tree, it can be a graph. So many such data structures are available. So let's begin our journey with a simple thing called a linear data structure. Welcome. So the linear data structure, here the elements are arranged sequentially and each item has a unique predecessor and a successor except for the first and the last elements. So first element will not have any predecessor and the last element will not have any successor. Other than these two, any element will have one predecessor and one successor. And the accessing of these elements is done in a single level order and is done in single step, and the linear data structure are simple to implement and traverse. The examples of the linear data structure can be arrays, can be linked list, can be a stack or a queue. Stack and queue are special versions of linear data structure. These two can either be implemented through arrays or through linked lists. So let's begin our journey with the simplest of the linear data structure, that's an array. Array uses a contiguous memory blocks to store the elements of the same type. So first thing, the data should be of the same type and all these data are stored in contiguous memory locations, that is one after other in sequence they are stored. And to access any element, we can make use of random access via using their index number, and because of randomly accessing is possible in the arrays, in one step we can access any data from the array. So in the olden version like C, C++, we had static arrays where the size is fixed because the size has to be defined while writing the program or before converting the program into an executable file. That means before compilation, this size of the array has to be defined. Therefore, once compiled, the array size cannot be changed and hence it's going to be a fixed size array and it is usually called a static array. Yeah, recent languages like Python, Java, they do have uh, arrays which are dynamic in size. That means they don't depend on the compilation. As and when we are running our code, we have a freedom to modify the size of the array, and because of this, a lot of benefits we can find in dynamic arrays, but let us stick ourselves to C language. So we deal usually with a static array. So how the array in C is defined? An array in C is defined as a contiguous locations in the memory as a block, and these elements 2, 4, 8, 12, 16, and 18 in this example are the elements of the array, and they are identified through the indices 0, 1, 2, 3, 4, and 5. So if an array has a name A, then A of 0 will be 2, A of 3 will be 12, and so on. So we can uh, access any element directly without moving from one point to another point. Just we can jump directly to the any location we want. So it's a random access possible. So why do we require arrays in first place at all? So they are efficient to store and manage multiple values of the same data type under a single variable name. So instead of having different names for each data, we can have one name for all the data which are somehow connected to one another. Logically, they have some connection and they have same data type. Then all the data can be put under one umbrella called an array. One name is given to the array and the indices are used to identify individual elements defined under that array. So accessing using the multiple data of same type becomes very easy to store as well as to work with. So here an example is shown for a C language. In C language, if I want to create an array, so we define name of the array, and in the square bracket, we define what the size of the array is. So we have to define this in advance so that during the compilation time, so much of memory will be reserved for this particular array name. And then we also need to define the type of the array because each data type requires different amount of memory. For example, if we say integer, then C language makes use of 2 bytes of memory for storing an integer. It makes use of 4 bytes of memory to store a double, and so on. So for different data types, different bytes of memory is required. Therefore, once we define int for this particular array, and if we say there are 10, then 10 locations, one after other, are reserved, and each location will be of 2 bytes because we need to store one integer in that location. So 2 bytes, 2 bytes, 2 bytes, 2 bytes, 2 bytes will be reserved for this array, and they said that there are 10 elements in that. So we want to store maximum 10 elements in that. That means 2 bytes each, 10 elements. So totally 20 bytes of memory is searched in the memory RAM, and wherever 20 bytes of memory is available, it is reserved for this array called ARAY, and the first location is uh, written as the starting point of array ARAY, and we have various elements here. So we can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements we have, and these 10 elements occupy 10 different places. Each place is of 2 bytes wide, and each location is identified by an index 0 to 9 because we have finally 10 elements. So 0 to 9, and if I want any element to be used, say the element 10 I want to use, then I can just use index 3 because element 10 is the fourth one in this array, and the array index starts from 0. Therefore, the fourth element is referred as 3. So ARAY square bracket 3 means it is this particular element 10. So the key operations possible in arrays and their complexities. So want to create an array, just the previous example we have seen. To create an array, we need to define. So we have two ways of working on that. One is just define that we have an array of size something, and just to define that, it's one step activity, but we can also add numbers to the array, then each number is saved onto different locations. So if we have n data in our uh, array while creating it, then we need to save n times. So it's usually order of n. But if we are just creating just one array by its name and not adding anything, then it will be order of 1. For accessing any element in the array, it's just a one step activity. Just say which is the index from where you want to read the data. Just give the index, the data comes out in one step. So order of 1, big O 1. If I want to appending means, yeah, I'm just trying to append at the end, provided the size of the data we have in the array is less than the size of the array defined. So if array is defined for n, then as long as the elements in the array is less than n, we can keep on adding new element onto the end of the array. So just appending, so we know where the last data is, just the next position, add a new one. So that's order of 1 if we know where array is ending. Otherwise, we can make use of amortized. That's where we work with dynamic arrays. So we look in details about this. So want to insert or delete at the middle. So you want to insert in the middle, then wherever you want to insert, that position has to be first cleared. Therefore, from that position onwards, each element in the further cases have to move one step ahead. Therefore, we start from the end, move it one step, the one back, move one step, then move one step, then move one step. So that's how we do. Therefore, it takes order of n, so we need to move n elements at the worst case. So even if you want to delete any element in the middle, we can't keep it blank. So we have to shift the further elements one step behind. Therefore, worst case, n elements have to be shifted to the left in case of the division, or to the right in case of the insertion. So in case of searching, we have two options. If the uh, data in the array are not in order, then we don't have any special way of searching. So we have to start from the beginning of the array and look for what we are searching. Is that what we have searching for? Is it in the first place? If no, then look at the second place. If no, then third place and fourth place till we get what we are searching, or move out till the end of the thing and still you don't get it, then declare that such a thing doesn't exist. So when you stop somewhere where you get that element, or move out and still don't get it, only then declare that such an element does not exist. So in case of unstructured data, then we have to go linear search, then it's order of n. So worst case, all n values have to be looked at. But luckily, if these data are sorted, then we can make use of a binary search. Then in just log n steps, we can either reach the place where the data is, or we can cover up all the elements and say that such thing does not exist. So worst case log n, we can solve this problem if it is sorted. So let's look at how the array is created. So to create an array, we define what data type this array elements are made of. So integer is the data type we are working with. ARR is name of the array, and in the square bracket we have given 5. That means maximum 5 elements can be stored in this array called ARR. Once this left hand side is executed, then 5 spaces, 2 bytes each is reserved for the name ARR, and in future whenever we refer to ARR, it goes to those 5 locations. Depending on the index, one of the 5 locations it's going to go. So we can say 2, 4, 8, 12, 16 are the elements of the array. So here we are trying to initialize it, and this is where they get into memory, and these are the indices for each of the element. So if I want to access, then the accession is done through the pointers, and the values are stored, and we have pointers. So these pointers will be used for knowing where the initial value is for the array. So PTR stores the address of the first first element of the array, and then PTR plus 1 will tell where the second element is, PTR plus 2 will tell where the third element, PTR 3, and the fourth element, and so on. So these are the different ways we can make use of while looking into the arrays. So when we are working with arrays, actually in the background we are making use of the pointers and working with that. So just looking at an example of accessing and saying that random access is possible. So we just define an array ARR, and we initialize with 5 values 2, 4, 8, 12, and 16. And then if I want to print the third element of this array, that means third element means because the array starts from index 0, therefore the 0th index means first value, 1 first index means second value, index number 2 means third value. So we are looking for third value, therefore we need to use index 2. Therefore I am just trying to print ARR index 2, it will print the third element. If I want to print the fourth element, then I will say ARR 4, if I want to print the first element, then I can say ARR 0 and so on. So that's how the things are done. Now, looking at how this is being executed. So this one shows that the code we have defined an array ARR which is of type int, and 5 elements are initialized, and then we said print the third element, print the fifth element, and print the first element. So the third element, one, two, three, third element is 8, then fifth element is 16, and first element is 2, and we can see here that in the beginning the value 8 is printed, then 16 is printed, then finally 2 is printed. So that's how the values are array is defined, type of the array is defined, the values in the array are initialized and accessed randomly. So we can randomly access any element in just one step. Therefore, accessing of any element from the array is of 0 or one step ahead, so order of 1. So for now, that's it. So we see many more things to come. So keep watching. Thank you.